in the early years of this century, Frank Zeider and I were, he was doing a PhD on reversible computing, and between us we wrote a reversible forth, and it was written in native forth and C. GCC 5, I think, was the current manifestation at that time. Forth, Frank was a very strong programmer, didn't know that much about Forth at the time, although he wrote his own Forth system almost immediately. But he chose to write the sets package in C. And he wrote a very complete sets package. You can have sets of any size and type within the memory limits of the computer. Unfortunately, his style of programming is very difficult for me to follow. His make files are of immense complexity. But this after Frank left, every time there was an update to GCC, this system had to be coaxed into life again. There were always problems, there were always things to resolve. So we managed to keep it going for years. But a couple of years ago, support for 32-bit GCC was withdrawn, and the last version that was left was completely unusable. The heap management just didn't work at all. So this system, I didn't have the time to rewrite it to keep it up to date by transferring it to 64-bit. Also, a 64-bit system would be less useful from my point of view. If I'm talking about this, if I'm writing about it, I'd much rather be writing about 32-bit patterns than 64-bit patterns. With 32 bits in hex, you can easily describe -1 or something like that if you have some point to make. It becomes tiresome in a 64-bit system. So 32-bit, the whole Forth is written for exploring ideas and basically seeing what mathematical ideas we need to formalize what we're doing on the computer. So that's been a long research, which we finally published the mathematics behind it just last month. And 2 years before that, we published the programming before it. And these were in top journals. So we're very pleased with the results. But we would like to keep this system going. So I was encouraged to look at containers. And I did so. I looked at Docker. I found Docker provides a way of encapsulating what software you need that you've run in the past, that's run nicely on your desktop, but doesn't run anymore, and perhaps won't run on someone else's desktop that you send it to. So you can set up a container that contains the environment that was successful for you when you created when you compiled your system, in our case. So Docker provides a repository of ready-made containers, and I found one that had 32-bit Ubuntu and nothing else. It was a very bare-bones 32-bit Ubuntu. And so I loaded that, and then I had that Ubuntu running in a terminal window. So I had a 32-bit Linux running in a terminal window. I was able to download GCC 5 and bin utils, which we need. A lot of our work is, our meta-compiler generates 32-bit Intel assembler, which is compiled by GCC and linked with the C sections. I would have preferred, in a way, to know what the memory image format is so that I could generate my own memory images, but I didn't have time to look into that, so we got round to that by using GCC, that looks after creating our memory images. It wasn't an entirely painless process because our aim was to run to provide a 32-bit compilation service. So our container has the 32-bit compiler loaded. The containers should provide an ability for you to link your files from your memory system into the containers into the container system's memory. But this was broken on Ubuntu. So I tried to uninstall Docker. That completely broke Ubuntu. So I had to install Fedora. That worked. I was able to link my Forth source files into the memory of the Fedora 32-bit Linux, and I was able to complete my compilation, just obtaining a 32-bit compiler service, a GCC5 compiler service, from the container. But I'm just working in the 64-bit system, and so now I'll just pause for a moment and try and get something on the screen. So Docker provides a repository with ready-made containers. I didn't have to know how to create one from scratch. I was able to take one that was already offered on the repository, modify it by compiling into it all the tools I needed, and then I posted it back to the repository with a different name. Okay, so this should run my meta-compiler. We're in a terminal window in 64-bit Fedora 40, and it's going to use compilation services from the 32-bit system. And it's going to do a lot of checks. So most of the comments printed out are just from the script, giving the results of testing whether the Docker daemon is running and things like that, because it's quite a fussy system. So now it's running in the 32-bit system. So we're getting some successful compilation messages. That was taking place in the 32-bit system. And when it exits from the container, it returns to the 64-bit system. So you can just write a script that spans over some work in the 64-bit system and then some work in the 32-bit system, and seamlessly comes back to you in the... Now we're back in the host directory. This is on the 64-bit system here. I found this a bit fastidious to use, and the documentation is absolutely, it's not the best. But it gives it is an incredible thing that you can get a stable system. Because what's really strange about computing is that you can't write something. If you prove a mathematical theorem, what the mathematical theorems we proved in 2000, the proofs are still correct. But the code we wrote in 2000 doesn't run without a great deal of effort to coax it into life again. And this is very time-consuming. And also, it's much more difficult to share what you share what you do. It's running in this particular Linux at the moment, but it won't run on someone else's system. So you can box up the software that you're using, and it's very encapsulated. So all this provides is 32-bit compilation services. The container's got, you can shut off any access to networks or the internet. You don't have to shut it off. So initially I was able to have my container accessing the internet so that I could compile from the Fedora, from the repositories associated with the 32-bit Ubuntu system. I could compile GCC5, etc. So at that point I could have access to the web. But when I want to use it, I can shut off access to the web and just call upon the compiler services, which seems to be a very secure way of using a technology like this. What we saw running here is a little bit different from what happens when you run it for the first time. The container that I made is present on this system, so it doesn't have to be pulled from the internet. You can't see it in the file system. It's looked after by the Docker application, which is a bit unnerving because you can't see what you've got, but it works reliably. The first time you run it, it will say, oh, this container isn't present, and it pulls it from the Docker repositories. It's incredibly efficient. Even that happens almost instantaneously. So a very interesting technology that deals, in fact, with a problem that shouldn't exist, because why can't we write software that will work in a general environment. So I think the answer is that nobody, when they provide software, really tells you what it does. I've always found that you have to find out what various things do by experiment. You have to try it and say, oh yeah, it's doing that. And you build up a theory of how it works. And it's the scientific method in practice. But unlike God's universe, where the laws of physics don't change, the laws that you're working to change every time there's a new release of GCC or a new release of the operating system. And you have to again find out what it is. And that's okay for yourself, you can do some experiments. But for other people that are trying to use your software and don't have the same time to invest, it's absolutely intolerable. Well, so if you accept that because of a lack of documentation, because people know how to write code, but they don't know how to say what it does. That's my conclusion. Or perhaps it's not so much fun to say what your code does as it is to write it. Because code is being written. You know, we're under an avalanche of new code all the time. We're not got anybody that's going to tell us this is what it means, this is what it does. So no one's ever published the semantics of the C language. What it does, you know, is just what experienced programmers know it does. And so at least with containers, we seem to be able to stabilize the environment, so we don't have to do this experimentation every time. But this experience left me with more questions because I'm a newbie to Docker, and this is the only time I've used it. I don't want to just work in a 32-bit system because the main day-to-day work of my Forth system, okay, it's a reversible system. It's used for informing our research, but its main day-to-day job is for writing. It typesets mathematics papers. I find LaTeX, which I learned from Peter here, very difficult to use because my brain can't cope with the very heavy symbolism. When you look at a page of LaTeX, it doesn't look like the mathematics you're trying to write, because instead of writing some funny sort of bracket, which you recognize as, say, a denotational bracket or something, you have to write the name of it, or you have to write \alpha instead of writing alpha. So we have a maths preprocessor that works with LaTeX called high-tech, and the source code of our maths papers you can read as a mathematician. You don't have to know any LaTeX to read it. So that's what this Forth system is doing every day. It's typesetting all our mathematics papers. So that has to run on a 64-bit system because we're using the current versions of tech. But our compiler services have to be provided by a 32-bit system. But
have you ever used Omega?
Omega?
Yes.
No.
Omega is tech, but with Unicode, so you can type the alpha character and it will process it as the alpha character.
There is a UTF-8 extension which gives you some characters. In fact, I can type alpha, but I can't type. I mean, I've got a couple of hundred mathematical symbols, and
yeah, sure.
They're not all provided for. So I've not seen a complete solution. It's very symbol heavy, our stuff. You know, there is an incredible number of symbols used.
There are, and I don't see an easy way around that, to be honest.
So but I'm happy with how we've got round it using Forth. Forth is a wonderful language to do typesetting with.
And your editor does a reasonably good job of this.
Yeah, we can type in the Unicode symbols as well. Yeah.
But Omega was designed explicitly for this type of problem.
Yeah. There's also LaTeX that does a better job, but that generates files that are not accepted by all journals.
Yes, it would.
Yeah.
Because LaTeX is, you actually embed Lua script inside your tech code, or inside the PDF even. So. That's not acceptable.
So yeah, I mean, when the last journal, I had to upload my tech files, and they did the compilation, and it wouldn't work.
Oh, that's awful. There's so much configuration that you need to do. That's insane.
I mean, it's purgatory. You know, you've written your paper. It's going to take you 2 weeks working all day, every day to get it through the interface provided by the journal.
Absolutely.
And eventually they told me how to cheat, because it won't accept your PDF. It's not even accepted. You're just trying to present it for review. And then they said, well, if you do this, you can load the PDF file of the paper as one of the auxiliary files, and it will get through, and the reviewers will be able to see it. So that's how it got to the reviewers. But then when we actually had to publish it, of course, we had to face up to the more serious problem and do it properly. It took ages.
Yes, and that's because every LaTeX system is configured slightly differently.
So what else can we do with containers? Can you have containers seem to be mostly designed for people who are providing web services. But could you have a 64-bit desktop frozen as a container?
Yes.
Yes.
And using Xwindows, or not Xwindows, whatever the modern equivalent of Xwindows is. Could that be done?
Yes.
It is already done.
It's done.
So I would not say it's mainly for web people. I mean, yes,
that's
where it was invented, and that's where it feels closest to home.
Yes.
But if you Google around a bit, you can get the Windows system connected to it. You can get X connected. Not sure about Wayland, but I'm sure there's some way of doing it. So yeah, you could do that. So really, just as you said, it's hard to configure LaTeX correctly. Containers to the rescue. You can get a
LaTeX Docker.
Yeah. Take a LaTeX Docker. There's everything you want in there.
Yeah.
That's just, a modern way of shipping software, which is, I think also your question was very valid. Why can't I just run this old code? But if you think about all these dependencies there are,
yes,
there just comes a point where there's 10 versions of the same libraries and they're conflicting. Now, of course, I agree, there should be a way to resolve the conflict, but in some systems there is not.
Generally there isn't,
Yeah.
let's say. Generally there isn't. The world we live in doesn't operate.
Oh, well, again, when there are systems which do, like NPM or the force.net. Both of them have very strict versioning, and you can include by version number. So that means you can have an arbitrary amount of different versions running at the same time. And maybe that's the way forward. Maybe not. It's also hard to maintain all of this.
It's very hard to maintain that, and very hard to be sure that it's all correct.
Yeah.
That takes a lot of work.
Absolutely. Any further comments for Bill?
Maybe not for Bill, but in general. So people say that Docker and containers are the solution to doing this kind of keeping old stuff around. And then, at some point the kernel drops some features like old binary formats. And so, and then the next step is to use a virtual machine and run an old kernel in the virtual machine and run the old software on the old kernel. And at some point, the virtual machine doesn't support the old kernel. So this is, there is a colleague of mine has a problem. He uses a hugely old system, like from '99. And the virtual machine that they tried it on does not support this old. So it has more modern hardware that there is not more modern virtual hardware that is not supported by the old kernel.
In that case, I think you have to go to emulation then at some point instead of virtualization.
Well, that virtual machines are emulation.
Yes.
No, but I mean really like what the retro computing people do, just maintaining that part and not trying to have a proper virtual machine being.
Well, anyway, so my worry is that this all these ways of getting old software to run in degraded systems are an excuse for those people who don't want to maintain backwards compatibility to say, well, we don't need backwards compatibility. We just use some container and so on. And I think that's, yeah. I think this will not work in the long run.
Okay, thank you. Any further comments? Bill, something more you want to add to this?
I found the Docker daemon a slightly fastidious animal. And in my script, you can ask if it's running, and you can start it if it's not. So it's not too bad. But if you just try and start it when you start when you boot up Linux, and then assume it's running, that's not going to be a 100% solution. So why was it written with a daemon?
Well, I believe you're saying there's a version now without a daemon.
I was going to suggest that very thing. So Docker was just the first time trying out this kind of architecture. But since now there's different things, a lot of different things actually, and I would recommend using Podman, which runs without a daemon. It's very light. It has the same syntax, so you can just, instead of writing Docker foobar, you can write Podman foobar.
What about the repository, though? Does it?
It uses all the same stuff.
It uses the same.
I'm saying it's a drop-in replacement. No strings attached.
But it can't coexist with Docker. I'm going to have to.
It can do what?
It can't coexist with Docker, I think.
I wouldn't say that. Maybe
Okay.
it can. But what I normally do, I only install Podman. Then I make a symlink from doclink or an alias from doclink to Podman, and I never notice the difference. I mean, I don't notice the difference when I look at stuff, but it just works. I don't get an operational difference there. There are also some benefits, like you can have a lingering systemd. That means that if you run a server and you want to run your system there in the background, for example, as a user, you can do that, which is, I think, not that easy with Docker. I mean, yeah, they would just run in the Docker daemon. So, but yeah, I think Podman is a good solution. And what I would like to ask you is, where can we find your work? Is it published anywhere?
So it's in these proceedings.
It's in the proceedings, right? Yes. I'm asking also for the internet audience.
Yeah.
So yeah, maybe we can just update your description to just provide a link to something, to how to do it. But yeah, okay, that's
Thank
wonderful.
you very much.
Thank you very much.
And thank you very much for the suggestion last year.
You're very welcome. Welcome. Glad it worked out for you so well.